At your local community center, youth basketball players are being evaluated to be placed on teams. The first order of business, the coach asks the players to rearrange themselves shortest to tallest. Just because the players are lined up in a different order doesn't mean that the coach is looking at different players. We have a property in addition and multiplication that is like the community center. The word commutative comes from commute, or move around. So the commutative property is the one that refers to moving stuff around. When the only operation is either addition or multiplication, then the terms can be moved around in any order and the expression will have the same value as its original. For example, 1 plus 2 is the same as 2 plus 1. Regardless of the order of these terms, we know both expressions are equal to 3. So how is this property helpful? Let's take a look at another problem. When determining the sum of numeric expression with more than 2 terms, many people find it easier if the terms which equal to 10 were together. Of course, this means you should be able to identify the pairs of numbers that equal 10. Try it now. On your paper, write down all the numbers that you know that add up to 10. You should have 1 and 9, 2 and 8, 3 and 7, 4 and 6, and 5 and 5. Now, if you're yelling at me right now, Stacy, what about 6 and 4, 7 and 3, 8 and 2, and 9 and 1? Well then, you're demonstrating that you already know how to use the commutative property. This same expression can be written like this, which can help us to easily calculate the sum. Since 1 and 9 is equal to 10, 3 and 3, we add it together, equals 6, and can be paired with 4 to equal 10. Adding this expression should be pretty easy now. 10 plus 10 is 20. The factors in an expression can also be rearranged in any order. Perhaps it's easier for you to multiply the two largest numbers first, since it's not difficult to multiply a large number by 2. So you would rearrange the terms like this. Warning, these properties do not apply with mixed operations. I know this expression 1 times 2 plus 3 times 4 plus 5 is equal to 19. You'll learn why in an upcoming lesson. For now, watch what happens if I reorder the terms and factors in this expression. Let's just pretend I wanted to reorder this expression in descending order. I recognize the identity property of multiplication. Do you? So I know I don't need to worry about the 1. Again, in an upcoming lesson, you'll learn why 5 times 4 plus 3 times 2 equals 26. Since the reordering of the terms and factors in this expression do not yield us the same results, we can't use the commutative property to interpret the expression with mixed operations. The commutative property can also be used on algebraic expressions. Let's look at an example of the factors of b and 2a. There is a standard order of the factors in a variable term. The product of all the variables' coefficients should always be written first. What is the coefficient of the first factor's variable? Remember, when you don't see a variable's coefficient, it's 1 due to the identity property. So 1 times 2 is 2. Remember, we can show multiplication of a coefficient to its variables by writing them side by side with nothing in between them. But the standard format the variables in the term is in alphabetical order. Therefore, we would write AB. Since the only operation in the original expression was multiplication, we were able to use the commutative property to rewrite these factors into one simple algebraic term. Now you try it. How would you rewrite these factors in standard form? First, you would multiply the 3 times the 2 to get the coefficient of 6. Well, 3 times 1 times 2 to get the coefficient of 6. Then you would write the variables in ABC order, which in this case is x, y, z. The commutative property of addition is useful for a very frequent action in algebra, combining like terms. Before you can combine like terms, you must identify them. How many terms do you see in this expression? I see 4. Remember, terms are separated by plus and minus signs. Terms can either be variable terms or constant terms. What are the like terms in this expression? 2x and x, positive x. Remember, all the terms have signs, so include them when identifying your like terms. The reason for this will be explained in detail in a future lesson, but for now, remember to include the sign. The second term is not a like term to the 2x and x because it contains another variable, y. We can use the commutative property of addition to rewrite the expression with our like terms together to make it easier for us to see what can be combined in the expression. When you combine like terms, you will add the coefficients, but the variables stay the same. Therefore, 2x combined with x is 3x. The rest of the term in the expression cannot be combined, so you will bring them down. Notice how I wrote the variable terms in ABC order, followed by the only constant. Now this expression is in standard form and simplified. You try it. Simplify this expression with the commutative property and combine like terms. You should get 5x plus 7y plus 3. Therefore, the commutative property is helpful for adding terms together, which we will forevermore call combining like terms.